Right, so welcome to part 2 of my simple platform game demonstration on Game Maker Studio. So we're just going to carry on from the last video where we made a few changes to the code which allowed the player to move from room 1 to room 2. Now in this second part we're going to add a second character into the game, which is going to be the enemy or the villain. So this is the main character at the moment. This is the player, and we've got him in a room here. So this is room 1. What we're now going to do is we're going to add our second character, which is going to be the alien. So I've just modified the player sprite, flipped it, and then colored it and given it a bit of a jetpack on the back. I'm just gonna flip the sprites now. So if you go to image, and let's see if we can do it via mirror. So we go to mirror all frames. So we've got the alien facing towards the right. This is so that we can have the right, we can have the sprite facing the right direction when it's walking left or right. So just close these. So we're going to check now is the origin. Now what the origin is where the X and Y position of the sprite is. So if you put 0, 0 as the X and Y positions, this will be the center of the sprite here, which is 64 by 64. So we can make sure our alien sprite is the same. So we need to put this middle center, so that's also 64 by 64. So that's set. What we're going to do now is create a new object. We want our new object to be similar to the player object, because again it's going to be moving left and right. So let's create a new object. So we right click on the objects asset, and then create and select object. Now for this one we'll name it enemy, or you can have it as enemy1. And then we select the sprite. So we selected the alien sprite. Now we go into our room 1 or room 2. What we can then do is we can then drag the enemy onto the room itself. So I've got it positioned there. So what we're going to try to do is have the enemy walking left to right on this platform here. So that when it comes to the end here, it's going to turn around and walk back. When it comes here, it's going to turn around and walk back. So it's just going to carry on kind of like patrolling the top of this hill. And our player would have to get past it in order to win the game. So several ways you can do this. So what we're calling is the enemy AI. So we're going to program the enemy to simply walk and patrol the platform that it's currently on. We need to add code so that it knows when to stop and when to turn. So let's just do that. So let's start now by going into our enemy object. We need to add a create and also add a step event and also a collision event. So we can do collision detection with all the existing objects, such as the player's bullet. So let's just do that one. And also collision detection with the actual player. Now we go into our player object. We can see all the variables that we had in order to control the movement of the player. So we're going to copy these into the create event of the enemy. Okay, so we're just going to have a look at which variables we're going to need. I don't think we'll need MSD and game over because these were used by player object. We'll need bullet speed because we're going to have the enemy firing bullets. So we've got the movement speed. Jump speed we're not going to need because at the moment we're not going to be jumping the enemy. So now let's go in our step event. Now what we have to remember is for the player, the left and right and all the other movement was controlled using the keyboard. Now for our enemy, it's going to be kind of powered by the AI or the code. So we need to kind of define its movement rather than the keyboard. So there's different ways we can do this, but we're just going to try the simplest way. So what we're going to do is we're going to replace the keyboard checks with a variable. And our variable is going to be called direction. Now direction is a built-in variable, as you can see there. So you should need to be a bit careful when using it. So when we start, the alien is going to be walking towards the right of the screen this way, and this is 0 degrees. So to start with, our direction will be 0. And go back to step event. And let's replace the relevant section here. So going right would correspond to keyboard check D, or the right VK right keyboard check. So we're just going to replace the keyboard checks with direction check. So if the direction is equal to 0, this means it's going right, or move right. So then we're going to check that there's no objects in the way, and if the way is clear, we're going to increase the X, and we're also going to set the image speed to 0.2 so that it looks like it's walking. And we'll also set the bullet direction so that the bullet direction is the same direction that the alien is walking in. So that should work. Next thing is what happens when we want it to go to the left. So we're going to replace the keyboard checks for VK left with the direction of 180, because going to the right is 0, going up is 90, and going to the left is 180. So 180 is moving to the left. So if you just join, this is a Game Maker Studio, and we're using the Game Maker language to code enemy AI. Very simple enemy AI to make it walk left to right on a platform. So this is the step event for the enemy object. Now at the top here we've got the keyboard check W and keyboard check VK up. Now we're not gonna really need this because there is no up for the enemy. It's just gonna go left and right. So what we can do is we can comment it out. The way you comment out Game Maker code is you just put the / followed by an asterisk, and then to end it you just put an asterisk followed by / again. So this code is now commented out. Okay, so now what we've got here is we've got the code for going right, we've got the code for going left, and now we're just going to check the other code so that we're only using code that we need. Keyboard check release A and keyboard check release D. What we can do is we can define a moment where the alien will be standing still, in which case we can have something like direction equals -1. So if the direction is -1, that means we're gonna stand still, in which case the image speed would be 0 as well. This is a code to handle jumping, so we don't really need that either. So we can just comment it out. In this case, what I'm going to do, I'm just going to copy this code here, and then comment out this entire section here. That's for handling jump. We still need to use this code here because this code is going to stop the enemy object from falling through the solid ground. So what this code is doing is checking to see what's 2 pixels below the enemy object sprite, and just to check whether there's ground there. So our ground is called ground object. In our case, ground object is a parent object. So we go to ground object. You can see the children are ground half. So any object which is either ground object or has a parent as ground object is going to be seen as the solid ground object. So we right click here, go to object enemy, currently working on the step code. Now this code here is used to fire a bullet. So we'll work on this later. So for time being, we'll just comment this out. Okay, so that should set it walking, because when we start the game, or start the room, it's gonna start walking right, because the direction is 0. And this is a step event, so if direction is 0, it's gonna start walking to the right. However, what we need to do is we need to make sure that when it comes to the edge of this ledge here, it's gonna stop and turn around. So the way we're going to do this is, again, we're going to use place meeting. So now if the enemy is walking to the right, direction equals 0, we're going to do a check. For no ground. And I will just put curly brackets. And then if it is true, then we want to exit from here. And we're going to flip the direction. So if we're walking right and there's no ground there, we tell the enemy to turn around and start walking in the other direction. So we're going to set the direction to 180. The next thing you do is we need to tell it where to check. So we're going to tell you to check x plus 10, y plus 2. Now this could work, or we might need to increase the y to y plus 10. Let's just try this. Now what we're going to do is we're going to copy this code and then put it in the code for when it's going left, which is here. Now in this section, when the direction is 180, we're going to move to the left. However, we need to flip the direction to 0 if we get no ground. Now in this case, we need to check -10, so x -10. So we're checking 10 pixels to the left and 3 pixels down on y. Check for ground object. So this should flip the direction. Now the other things here that we kind of selected are the collision events for collision with a bullet and collision with player. Now the bullet is fired from the player, and if the enemy is basically shot, we need to basically make the enemy die. So the way we do that is we're going to set the health or the life. Again, health is a built-in variable. So we're going to set the health as 100. Now, every time the enemy is shot by the bullet, we're going to decrease the health by, say, 25. So it needs to be shot 4 times, in order for it to be killed. So what we've done here is health minus equals 25. Minus equals is just a simple abbreviation for health equals health minus 25. So both of these lines are exactly the same. Health minus equals 25. Health equals health minus 25. It just makes it easier. So once the enemy has been shot, we've decreased the health by 20. We need to now check for whether the enemy has actually died and then destroy the object. So we do a simple check if health is less than or equal to 0, in our brackets, can do a simple instant destroy. Now here, what you could do is you could have a script or a function which would be executed every time the enemy dies. And in that script, you could put something like score plus equals 100. So every time you kill the enemy, your score goes up 100. We'd also then need to define the score in the create event of the player object or somewhere else, like the count object or loaded object. As long as it's defined, some score as 0, which should be its default value anyway. Now the other thing was collision with the player object. Here what we're going to write some code to tell you what to do when it collides with the played object. So just to make it simple, we're just going to end the game. So we go back to our played objects and see what happens when the played object walked into the hole. And scroll up. It's in the outside room. So here it is, game over. So copy that code. Now the way we do it here is because game over is a local variable in the played object, we're gonna call this in the scope of played object. So the way we do that is we write with player. So basically all the code of this with player is gonna basically get executed or run in the player object. So it's as though it was called in the player object itself. So let's just try that. So what we're gonna write, so if when the enemy collides with player one, we're gonna show a question and telling the user that it's game over, do you want to try again? But we're gonna use with player so that the game over variable is assigned the value and that can then get checked in the player async event, which is a game over. Now, for testing enemy AI, what I tend to do is I create a room just for testing purposes. So in our case, what I'll do is I'll go to, like, for example, room 1 and then duplicate it. And I will just rename this to test room. Now this room we're going to use it for AI testing. So we can start off by deleting any existing objects. And then we'll just create a simple room for testing purposes. So because we're testing to see whether the enemy AI can walk left and right and avoid falling down, we're just going to create a ledge here, and then we're going to create blocks here and here, just to make sure that you can also avoid the walls. I'm just going to adjust the viewport. So go to viewports, viewport 0. Set the X and Y position. Just the X, actually, X, Y. So we're going to move this rectangle. So this rectangle is what the user will see when you start the game. So we need to move it somewhere a bit further up here. Or what we can also do is we can also just remove the viewport altogether so that we can see the entire room. Now let's drag our enemy object onto the instant ins objects layer and just place it here. Now if we click on to the left of test room in the assets browser, this tells us the room order. So we're going to make sure our test room is the first room, which is marked with that house symbol there. Now what we could do is press save and then press play just to see if there's any errors, because you might have some errors which you need to fix first. So as you can see, we've got the test room. However, our enemy isn't really walking anywhere, it's just stuck. So let's just try, see what happens if we move it up here. So it does move down and collide with the ground. I'm gonna add a global. When you're debugging or you're creating new kind of AI, you'll find you'll always need to keep going back and forth, compiling the game and just seeing if it works. So what we've got now is a problem where it's not actually walking left or right, it's just stuck. So our move speed is 4, jump speed 12, grounded is 0, direction is 0. We're just gonna have to debug that now. So our current problem is that the X position is not updating, so we're just stuck in the same place. So let's see if this is actually going to work. So what we're going to do is we're going to remove this check. See if that works. Just going to set the image speed as 0 in the create event. And we'll also do that in the players object. So what I've done now is I've just show debug message. What show debug message does, it will print whatever's written there into the output window of the game while it's running. So we can now see whether the code actually reaches this line here. Actually, this should be walking right. So walking right. So it does actually get there. And the next thing is we're going to check whether it actually executes the code here. So as you can see, it says here walking right. But the problem is, for some reason, it's not moving. It's not shifting the X position. Let's just try giving it a specific value like 5. Okay, so we know that does work. It's just for some reason it's getting stuck on the ground object. So if direction equals 0, it does go in here. Just place meeting. There's no object direction equal 180. So let's just put a debug message here and put switch direction. Just give me 1 second. I'm just going to start a live feed on TikTok as well. So if you've got TikTok, you can also watch the same live now on TikTok. So I'm just gonna start live. Okay, so if you've got TikTok, the TikTok username is Rizbit UK, all one word, RIZBIT UK, and you should find live on there as well. Okay, so the live is up now on TikTok as well. It's up now on TikTok as well. Okay, so now we're going to get back to the actual problem, and the problem was that the enemy object is getting stuck in the ground. So what we've seen is that it does actually get to this stage of the code in the step event. So it should be setting the x to x plus equals move speed, which we've also checked that it does work. So we need to find out why it's not actually moving. Okay. So the x speed is x plus equals move speed, so that should work. And image speed is 0.2, and image scale, x scale is 1. And the bullet direction is going to 0. We can also put an else here now because it's only going to go in one direction. It's either going to go right or left. So let's just give this a try. No, it's still not working. However, what we can see here is that it's switching direction. If you look in the console, it's giving the debug message which says switch direction to 180. Which in our case is actually wrong because it shouldn't. So it could be something wrong with the code. So we'll do x minus 10. Oh, so that seems to work. Now it's walking. However, it's walking off the actual platform. What we want it to do is to turn. So it's something to do with our place meeting here, x plus 10, y minus 10. So we just change it to 0. Not going to work. I think because we will check for not place meeting. Because if we get a positive value for place meeting, that means there's ground there. But we only want to check it when it's no place meeting. So this must be the reason why it's walking off. Okay, that seems to have worked. It's worked. However, it's walking a bit too far. So let's just change it to x plus 20. Now we'll have to change this code in the going left sections also. If we go to direction equals 180, this is when the enemy is moving to the left. And we'll have to change this here now as well. And this time we're going to check 20 pixels to the left of x and change the direction to 0. So what we're doing is we're just making the enemy walk from one end to the other end in our test room. So when it comes to the edge of the ledge, we want it to turn left, and when it gets to this end, we want it to turn right. So let's try this now. Oh, that's worse. The reason for this could be the exit here. Okay, so if you can see now, what I've done now, just created very basic enemy AI or enemy walking code. So when it starts, the direction is 0. It walks towards the right of the ledge, and when it comes to the end, it detects that there's no ground object here using place meeting code, and it switches the direction to 180 and it starts walking that way. And then when it gets here, it checks there's no ground here, and then it switches the direction to 0. And you can see all this happening in the console here, where it says walking right and then switch direction to 180, and then it's walking right. Okay, so let's copy this code here. Walking left. Okay, so this seems to work. On the ledge it works, so we're moving left and right on the ledge. And we've put the enemy object here. What we can see is it gets to the block and then it just stops. What we want it to do is we want it to, again, reverse its direction. So what we need to do is copy this code here. And then place it here under else. Because if there is an object, ground object, a solid ground object to the right, and we're walking right, then we need to switch direction. And then copy the same into the code for when it's going left. And this time switch the direction to 0. Just want to see if we can actually make this code any better by placing an else here and an else here. Okay, so the less conditions that you have to check in each step, the faster the code will be, so you'll get a faster frames per second. It's also going to optimize the code as well, so it's not having to check every little thing in every step, because this is a step event, so every step we're doing these checks. So let's try it now. So it's walking left and right. That's how we wanted it. And let's try at the bottom here. So as you can see now I've changed that code. It's also walking left and then turning direction when it's walking to a wall. So we can put it anywhere and it should actually work. So again, it'll work on here as well. So you can see it's walking left and right there, and also on the big. So what we can do now is, because we've got the enemy object and we've got the code in place, we can place as many enemy objects as we want. So we can put one here, we can put another one here, and we can put another one here. And they should all use the same code because it's different instances of the same object. They're all the enemy object. So these are all instances, and each instance has a different ID, and you can reference these IDs. So you could actually make changes to one particular instance, but they are all actually enemy, and they're all an object called enemy. They're all using the same AI. So we've done the basic AI. So what we're going to do now is just going to test it on our live game, on our actual game. So we've got the health when you get collision event with the bullet, and we've got the collision event with the player. What we also want to do is now we want to fire bullets out, but in order to fire bullets out, we need to test it with the player object. So what we're going to do now is we're going to create a dummy object for player. So we'll just create a new object, and we're going to call it dummy. And this is just going to be a representation of the player object without actually like being controlled. And we're going to place an object, we're going to place a dummy in our test room there. Okay, so in order to fire bullets, what we're going to do is we're going to have to give the enemy some kind of like vision. So we need to allow it to see the enemy, the player object. So whenever it sees the player object, it'll start firing bullets at it. So we need some variables such as the speed of the bullet, the interval of the bullets, and also how far the enemy can see. Now, there's also several ways you can do this, but we're going to use something called a collision line. So if there is a collision with a line taken from the center of the enemy, it will start firing bullets. So we'll go back into the enemy object. And we're going to create an alarm 0. Now alarms are just like what you expect it to be. It's an alarm, a timer, which you can set a value to, and then once the alarm is completed, the code here will get executed. So if you set the alarm as 10, after 10 steps, it will then trigger the code, execute the code in this section here, in this event. Okay, so what you're going to do is you're going to go to this section of the step event code where it's moving right. And we're actually moving the X position. So here we're going to do detection for firing a bullet. Now this is a very simple kind of vision AI. So we're going to use collision line, and we've got x1, y1, x2, y2, object, precise and not me. So we're going to click on that and then start filling in the values. So because we're moving towards the right, we're going to put x and y. So that's the enemy object x and the enemy object y. The horizontal is going to be x plus 200. So our enemy can see 200 pixels to the right of its x position. So if there is a player or a dummy object within that range, it'll start firing at it. So we just get the y position as y because we're going to be looking horizontal. The next argument is object. So because we're using dummy testing, we're going to put dummy there. And precise, we'll just put 1, and not me, we'll put 1 as well. Because we want to make sure that it doesn't like include itself in that detection. And then the other thing we're going to put is because we don't want it to continuously fire bullets. So we're going to like give it a time of say 2 seconds. So you can only fire bullets every 2 seconds. So the way we do this is we set the value of the alarm after we fire the bullet. And then in this condition, we're going to check for the value of alarm 0 is less than or equal to -1. Because when an alarm is completed, its value is -1. You could also put 0. So alarm 0 is less than or equal to 0. In that case, we're going to execute some code. The way we fire a bullet is just by going to the player object, going into step object, and we'll go into the code which was here to create a bullet. So we'll just copy it and paste it here. So it creates a variable bullet. We'll just call it e-bullet. So it's an enemy bullet, and it creates it on the layer. So that's some instant create layer X and Y position of the enemy object. And this is the instant, so be the layer name, and our bullet object here. We're going to make a new object. We're going to call it e-bullet, because otherwise we'll be detecting collisions with the bullet, our own bullet. After that's done, just got to change these here. E-bullet. Okay, so the enemy is walking to the right, and if there is a dummy object or a player object later on, 200 pixels to the right of it, and the alarm is 0 or less, we're going to create an instance of e-bullet, and we're going to set its direction and speed as well, using the bullet direction and bullet speed. Now, in order to make this work, we're going to have to move the bullet direction here to the top. So if the direction is 0, the bullet direction is 0. And we have to do the same for moving left. So we'll have to remove this. It's showing some errors, so let's just find out what the error is. Unexpected syntax error. So let me just check this. So you've got a missing bracket somewhere. Guys, if you're watching this on TikTok or YouTube. You can also share the live and drop me some likes just to show a bit of appreciation. So what we've seen is we've got some error codes here now. These error codes, don't know why they're there. Okay, so for some reason we had an extra bracket. Now we can do the same thing for moving left. So we'll go to this section here and paste the code here. This is the code for shooting a bullet. But this time we're going to check for 200 pixels to the left of our X position. We set the bullet direction here, so that should work. I just like to indent the code. Okay, now what we're going to need to do is we need to create a new object called eBullet. So this eBullet represents the bullet of the enemies. So if we go to our asset browser on the right here and then select bullet, right click it and then click on duplicate and then just paste the new name, which is eBullet. Now you can see eBullet here is defined and it's got the sprite there. You could change the sprite of the eBullet if you wanted as well. So we're just creating a very simple game, so we'll just leave it as it is. Now we can just press play, see if it works. I can see it's firing bullets out. However, it's only doing it when it's very close. So what we can do is extend the vision of the collision to make it see further. And the other thing which we didn't do is we didn't set an alarm. So we need to set the value of the alarm here. And we're going to set the value to 2 seconds. Now, an alarm works in frames, and each frame is 1 step. So we need to get the frames per second in order to set the alarm as 1 second. So what we're going to do is we're going to go to one of the built-in functions, which is game get speed, and then we're going to put FPS here, and we're going to use a built-in variable, which is the built-in constant, which is game speed FPS. Now this will be the equivalent of 1 second, because if the game speed is 60, then we're going to be checking every 60 steps. So we want 2 seconds, so we just put 2. So this should slow down the firing of the bullets. And the next thing we wanted to do was increase the collision line so that the enemy could see further. So we can increase it to say 500, which is double the distance. And then let's just test it again. So I think maybe 2 seconds is a bit too slow. So let's just make it 1 second. And possibly increase the distance to 600. can also divide it by 2 to make it half a second. So this will fire 2 bullets per second. What we can do with a dummy object, just for testing purposes, what we can do is create an event for collision with the e-bullet. And then what we can do is we can play a sound such as, a pain noise, or create an effect. We can do effect. We've got some built-in effect functions, so very simple effect. So we can do an effect create above, and we can select a kind of effect which is EF something. So we can use an EF explosion or an EF firework. We're going to choose an EF firework, and then the X and Y would be the X and Y of the bullet or the dummy. The size is going to be from, I think it's from 0 to 3 or 0, 1 and 2. So we're going to use 2. The color will just put red. So what this will do is it'll create a little firework to simulate kind of blood when it gets shot by the bullet. And then we'll make it invisible. And then we'll set an alarm for, just set a quick alarm for like 100 or 1 second. So we're using game get speed again, and then type in FPS and use a built-in constant, which is game speed FPS. So that's the equivalent of 1 second. Click on a draw event. Now in the draw event, you could actually edit or manipulate what's actually drawn on the screen for this dummy object. So if you just left it blank, it wouldn't draw anything, not even the sprite. So you wouldn't actually see on the screen. So in order to draw it, you would have to use a command built-in functions, which are draw sprite. And you can also simplify by using draw self. So this just takes all the default values for image alpha, image X scale, things like that, and just draws it on the screen. So what we can do is we put if it's visible, then we'll draw self. And then we're going to go and create an alarm event where we will destroy the object. To destroy the object, we'll just put instant destroy. So when it gets shot by the bullet, we create a little firework, a red color, set its visibility to 0, and then set the alarm to 1 second. After 1 second, the instant should just destroy itself, and while it's not visible, it won't be drawn. It won't draw the sprite. So let's just try this. I'm just going to add a command, add a event, which is so in our test room, I'm just going to create a test object, create a new object. I'm just going to call it test ob, just to give us an easy way to restart the game. So what we'll do is we'll go to test object, add event, and then we'll use one of the keys. So when we press the letter R, we'll just restart the game. Game restart. so we can test it several times in the same compile. It's not going to work because I need to put drag the test object onto the test room. Now it will work. So I'm just pressing the keyboard R. Now what the problem is here is it's creating too many fireworks. We just want the firework to happen once. And the reason why that's happening is because the collision detection with the bullet occurs several times per second. So what we're going to do is add a condition where if it's not visible, we'll just exit. So if it's already been shot once, it'll create. If it's been shot, it won't actually create any more fireworks. So you should only see one firework. There you go. So that's better. Okay, so that's done. So that's the basic. That's the very basic enemy AI. So I've made an enemy object and I've given it code to allow it to move left and right. It can avoid falling off a ledge, and it can also avoid walls, and it will walk in the opposite direction. So it's basically like a patrolling AI. It's just moving left and right. It's also looking 600 pixels in the direction it's facing, and it will try and detect a player or a dummy object and start firing at it. So let's just set this up so it works with our player object. So let's just add another collision line, and for this collision we're going to put player. So we're gonna leave dummy in there so we can actually use it in our testing room as well. So we're gonna check for player objects and dummy objects, and we're gonna fire them both. And let's just copy that above here as well. Change this to plus. Then change that to plus. See, what we can do now is we can also create that same firework here. You can use alarms to kind of slow things down, pace things out. So like in our event, when we colliding with the bullet, so the enemy is being shot by the player, we set the health to -25, but we also want to create like the blood effect. And because this is the alien, we're going to make the blood green, or we can make it blue. We're not going to set the visibility. We're going to set the value of alarm 1 to 1 second. Make it half a second. And then we'll do a check for the alarm. So if the value of alarm 1 is less than or equal to 0, then we'll create the effect and we set the alarm to half a second in this case. And we also want to do the same thing with our player object. So for our player object, we're going to recreate what happens with the dummy. So we go to collision objects eBullet. So this is the collision detection event between the player object and the enemy bullet. Now in this case, what we were going to do, we're just going to end the game. So if you get shot once, it'll be game over. So we're just going to copy this code, the game over code. We're going to add a draw event. So this draw event will only draw things if it's visible. And we'll use a simple draw self command. So when you get shot by the bullet, we're going to do the same checks as we did here. So we add an alarm one. Okay, so we've been shot. We set the visible to 0. Check for the alarm one, and then we're going to create a firework effect to simulate kind of blood splattering. And then we set the value alarm 1 to 1 second. And then after 1 second, we'll show the game over. The game over dialog. So I'm going to put that in the game over in the alarm 1 event. And the other things you can do is things like you can use the functions audio play sound. And here you could play a sound such as a pain sound or an ouch sound when the player is hit by the bullet. We still need to test this code, but let's just see if it works. Now there's one more scenario we need to account for, and that is what happens when the enemy gets to the edge of the screen. So we need to reverse the direction when it gets to the end of the screen as well. Now to do this, go to the any object and add a new event, which is other and intersect boundary. And the other way we can also do it is we could also check the value in the step event. So if we've got direction equals 0, that means we're moving to the right. We could add a check here. So if the place meeting, so if there's an object there in its way, we'll switch direction. Or if its X position is greater than room, the width of the room minus 20, make it 50. So when it gets within 50 pixels of the edge of the room, it should switch directions. And similarly, when it's walking left, direction equals 180. If the X is less than 50, we'll switch directions. And we can test this by putting an enemy object in the test room, or just by moving this one here and moving this one here. So you can see it doesn't actually walk off the screen. We need to change this here and put that in there, because that was wrong. Okay, so now we're going to set the default room as room 1 by moving test room to the bottom, and go to our room 1 and add some enemies in there. So we're going to put an enemy here, we put another enemy here, and here. So we've got 3 enemies there patrolling. And also in room 2, we can add another one here somewhere, but let's just edit the room. It will just create a little ledge there and put an enemy there, so when we climbing up the hill, we can avoid it. So let's just see what we've got so far in the live game, the actual game itself. So it's going to move the player using the arrow keys, and then press spacebar to fire. So as you can see, I'm getting fired at. I'm also able to shoot the enemy and kill it. Okay, so that's working. So the enemies are walking and patrolling and also firing at the player, and we can also fire back, kill them. So this is room 2. So there should be an enemy there who shoots at us. So we need to work on our jumps though. Oh, now the last thing we want to check is whether we actually get killed by the enemy bullet. So let's just get killed, shot by it. Okay, so we got shot by the enemy, but as we can see, we're still getting collision detection between the e-bullet and the player. And it's always triggering the async event. So we need to go back to our player, go into our collision detection. And then exit it if it's not visible. Let's do a quick check. So I'm just going to get shot by the enemy. So that's better. We only see one explosion, one firework. So that's just a little bug I can fix later on. But for this actual video, part 2, we've got the enemy AI working as we want it to. The only problem is we get this dialogue that keeps popping up. Okay, so I'm just going to end this live now. So we've got the basic enemy AI set up. We set up a new test room to kind of test the AI and create a new dummy object. So don't forget to follow me on